Think, Learn, Innovate.
Hi everyone. So today what we will do in the previous video, what we have done, we have charged the capacitor and we have found out the equation. Charging equation of a capacitor means we have done transient response of RC circuit with DC input. Where I have charged the capacitor and we have found out the equation, charging equation QT, the voltage across capacitor VCT, and the current and your voltage across resistance. In this section, what we will do now, we will find out the discharging mode of equation of the capacitor. So what we'll do today is the transient response of RC circuit with no source. Actually, I will not apply any source here. So what we'll do this, we'll draw this circuit at first. And we'll apply here a resistance and a capacitance like this. This is my switch and I will name this one A, B and C. This is my voltage which I'm applying here, and this is my resistance R, and this is my capacitance C, and this is my voltage across resistance, and this is voltage across capacitance. Now at first we will connect A and B. So we'll say at first A and B is connected. Now if I connect A and B, we will get the previous calculation, that is the transient response of RC circuit with DC input and connected for long period of time. I will connect this for long period of time. So if I connect this for long period of time, what will happen? These capacitors will get fully charged, and when this is fully charged, so the capacitance is fully charged with Q naught. So the charge of the capacitance is now Q naught, and we know what is this Q naught. Q naught is nothing but CV. Now what I will do after, say, when it is fully charged, we will connect the switch. Actually, we connect B and C together and we'll eliminate this voltage source from the circuit. Now B and C is connected and no voltage source is present. When the voltage source is not present in the circuit, so previously when this voltage was there, the KVL equation looks like this. The KVL but as this voltage is not here, my V is not present. So my equation is now VR plus VC equal to 0, or I can write down R into I plus 1 by C integration of I dt equal to 0. Now this charge I, what is my I? I know I is dq by dt. In the previous calculation, we have plugged in this I here. So we'll do similar thing in this case also. We'll say R dq dt plus 1 by C dq dt to dt equal to 0, or what we get, R dq by dt plus 1 by C q equal to 0. What I will do, I will multiply both sides by C, and what I get, RC dq by dt plus q equal to 0. So now my equation looks like this. So what I have to do, I have to solve this equation to get my total charge equation or discharging of a capacitor equation from this differential equation. So what I will do, I will take that equation, means what I got there, RC dq by dt plus q equal to 0. Or we can say that dq by q 1 by RC minus integration dt. So I will do again integration here. But remember in this case, actually, when my t is 0, when the switch is on, just put it on, the B and C is connected, that time my capacitor is fully charged. When the time is t, the charge will be qt. So if I do this integral, I will get ln q naught to qt minus rc t. So if I plug in the values of my integration, upper limit and lower limit, so I get this equation. So then what I get, ln equal to minus rc t. Or what I can write down, or I can write down qt by q naught is equal to what? E to the power minus 1 by rc t. So that's ln, this e comes to here and get this. So my overall charge equation qt is equal to q naught e to the power minus. So this is my total charge discharging equation of the capacitor. So qt is the discharge, the way the capacitor discharge following this equation. Now if I want to find out the voltage, to find the voltage, to find the voltage, so I will divide this qt by c. Then what I get? So what I get here? So this is my voltage equation of the capacitor. Now, what is the current equation of the capacitor? To find the current equation, the current flowing through the circuit is I, that is dq by dt, that is my d of dt of, q naught e to the power minus 1 by rct, like this. So if I want to find out the current, so my current equation will be very easy. So my current I is equal to, what I get, q naught minus 1 by rc, and I get e to the power minus 1 by rct. So what is my q naught? We know that the q naught is equal to cv. So I plug the value of q naught there. I equal to cv. In bracket I get minus 1 by rc e to the power minus. So my current is c. This c goes up, and v by r is I0 equal to v by r. So my current I, a function of t, is equal to I naught e to the power minus 1 by rct. So what we see from the equation, actually, if we write down all the equation which we got, actually for previous case, so the equation which we have derived, we got qt, and that gives me q naught e to the power minus 1 by rct. That's my charge equation. Then I got my charge across capacitance equation, voltage across capacitor equation, which is V And what I got is current equation also equal to. Now, from the above, all the derivation which I've got with all these three equations, we are seeing that all of them are exponentially decay function. That is, when t tends to infinity, charge, voltage, and capacitance all become zero. That means that after a long period of time, that circuit will get totally de-energized. And so it will stop working. There will be no current, no voltage present in the circuit. Thank you, everyone. I will bring back another video regarding the transient response of the RL or RC circuit.